In this question, we're asked to identify the oxidation state of the red atoms. Here I underlined them in red so we could see which ones we were talking about. Before we do this, I want to give you some general rules for oxidation states. There are exceptions to many of these rules. However, these are general rules for oxidation states. First, elements have an oxidation state of 0. Elements are 0. So if you have O2 or zinc, it doesn't matter if it's diatomic or monoatomic, just these things have an oxidation state of 0. In compounds, that's not true, but if they're an element by themselves, they have an oxidation state of 0. Typically, hydrogen has an oxidation state of +1. There are cases where it's with a metal, like in CaH2, where it's -1, but it's generally +1. Oxygen generally has an oxidation state of -2. This is the case for most compounds, but there are exceptions, like in peroxides, it doesn't have an oxidation state of -2. And in fluorine compounds, you can actually have a positive oxidation state on oxygen. 7A elements, the halogens, tend to have an oxidation state of -1. Unless they're bonded to something more electronegative than they are, such as if you have a bromine bonded to an oxygen, then bromine may not have an oxidation state of -1. So 7A is your halogens. And then another rule for oxidation state is for ionic compounds. And for ionic compounds, for monoatomic ions, oxidation state is the same as the charge on the ion. So the oxidation state is the same as the charge on the ion. Now this does not give us all-inclusive list, but it does give us a good place to get started. And you may be wondering, well, why do you need oxidation states at all? Well, oxidation states are an electron bookkeeping system that allow us to better understand reactions, such as electrochemistry reactions, which are very important for batteries and other things. So this is a very useful thing, even though it can be a little bit complicated your first time. So here we have O bonded to H and a minus charge. So oxygen here is going to have a -2 oxidation state. It's one of the ones on the list. In the next case, we have CHCl3, and we want to know the oxidation state on carbon. Notice that this is a neutral compound, this is a covalent compound, so carbon doesn't have a charge, but it does have an oxidation state. We're going to try to figure it out. Since this has an overall charge of 0, the sum of the oxidation states of carbon, hydrogen, and Cl3 must equal 0. So we have to use the oxidation states of the things that we know, such as hydrogen and the 7A halogen, chlorine, to find the oxidation state of carbon. To do that, we do it in a similar way as trying to find the charge on a metal, for example, in an ionic compound. So here we have C plus 1, because there's one hydrogen with a +1 charge, plus 3 times -1, because we have 3 chlorines, each with a -1 oxidation state, equals 0. If I accidentally say charge, I don't mean charge. These are not charges, these are oxidation states. So +1 for hydrogen, an oxidation state of +1, plus 3 times -1 for the oxidation state of chlorine equals 0. C plus 1 minus 3 equals 0. C minus 2 equals 0. Add 2 to both sides. C equals +2. So the oxidation state on carbon here is +2. We have another example, potassium nitrate with an overall 0 charge. In the case of potassium nitrate, I'm just going to move the paper a little bit so we can see what's going on. KNO3. We have a monoatomic ion. So in this case, we have +1 plus N, or just 1 plus N, because the charge on potassium is +1, plus N, plus 3 times -2, the oxidation state on oxygen, equals 0, because the overall species has no charge. So some of the oxidation state will give us the overall charge. Here we get 1 plus n minus 6, minus 6 equals 0. N minus 5 equals 0. N equals plus 5. So here the oxidation state on nitrogen is plus 5. So we'll go ahead and fill that in. And then finally we have CO2. In this case, carbon is unknown. We don't have a rule for carbon. So here we have carbon plus 2 times minus 2 equals 0. Move this up a little bit, so we have CO2, and we have carbon plus 2 oxygens with a minus 2 oxidation state each equals 0. The overall charge on carbon dioxide is a neutral covalent compound, so carbon minus 4 equals 0. Carbon has an oxidation state of plus 4. So plug that in here. It's very important to practice with oxidation states because it can be very challenging to do when you first start doing it.